Good morning. We're the team Aggie Warners, and this is our midterm presentation. So our team is comprised of two different disciplines. We have 4 urban planning majors and 3 computer science majors. So our problem is dictated by federal law that makes trains sound their horn at each crossing in the city of Nolanville. This is an issue because the train tracks run directly through the city of Nolanville. This creates an abundance of noise pollution, traffic delays, and irritation to residents and motorists. As you can see from the graphic that we have above, the train tracks run parallel with Interstate 14 and then head off in a northeast direction. This basically just divides the town into two, creating a lot of traffic congestion and mobility issues.
So our overall system design contains 5 main components, as you can see in the diagram here. The first one is the sensor. We'll be talking a little bit more about that in the next slide. But generally what it's responsible is for detecting whenever a train is passing on the tracks. And so once it detects such an instance, it will essentially record that data inside our train database. And from our software, is actually accessing 2 databases at the same time, the train database and the user database. And so from the train database, you'll be able to figure out instantaneously how fast the train is going and whether the object that was detected by the sensor is actually the train or not. And so once it has calculated these 2 things, it can then move on to figuring out how to send a message to all the users. And so we have a user database which contains all the people who are living in the Nolanville area around the train tracks. And so they will be the ones who are going to be notified. And so the way this is going to work is the software is going to, compile a message, and the message will contain something like the train is arriving in 10 minutes. And then it will also have access to all the users or the residents who have signed up for our program here. And then using the Twilio API service, it will send a message to all of the users who are around that area, and therefore notifying them whenever the train is passing.
So for our hardware, we have 2 components. We have the sensor and we have the Raspberry Pi module. So the sensor is basically what's going to be used to detect the train. It's using ultrasonic waves, which is sound waves. And what it does is, as you can see in the diagram, it sends out sound waves. And whenever there's an object in front of it, it reflects back and it measures the distance. So what we'll do is we'll connect the sensor with the Raspberry Pi module, which is a mini computer. And you can connect this using some wires. And you write software on this Raspberry Pi module to detect whenever the distance between the sensor and the object is less than a certain distance, then the train has arrived, and then the software will send a message to the users.
Here are some of our earlier alternative tech solutions to creating a train warning system. Our primary alternative involved using a camera to capture images of the train at regular intervals and running the images through a machine learning algorithm to determine if the images contain a train, signaling the Twilio API accordingly. The second alternative was to just use an infrared sensor and output a signal to Twilio above a certain threshold. The last alternative involved using 2 sensors spaced apart and using the distance between them and the time between train readings to estimate the speed and estimated time of arrival, and including that in the text notification. Each alternative would eventually trigger the Twilio service, sending a text message to all registered users.
Okay, to give a little bit of background information, there are a couple of similar systems that their prior work related to our sensors that have used real-time equipment status systems and IPAWS, which is an integrated public alert and warning system. In understanding the community issues, we're focusing on safety, communication, and community connectivity to really integrate the entire town of Nolanville all together. One of the causes of the train horn is it affects the tangible way of living and really disconnects the community by traffic congestion and creates a whole bunch of noise. So our primary impact is to solve traffic congestion as much as we can. And our secondary impact is to create a quiet zone. Different types of data, we are looking into emergency alert systems and wireless emergency alerts, such as text messages or alerts that go directly to people's phones. locally. Our community involvement effort is to conduct a public hearing, possibly the first week of April. We really want to give the community an opportunity to share their input on the train system.
All right, as far as goals and objectives goes, we paired our members with activities of their field of expertise. This way we improve productivity and efficiency. And as far as how each discipline will help the group achieve our goals, urban planners will advertise, contact the city and the rail track companies, and as well as engage the public with our project. Computer science will be responsible for programming, and civil engineers and electrical engineers will be responsible for the installation process. For major tasks, we have established a relationship with BNSF, which is the body that takes care of the road track in Nolanville. And we're also establishing a relationship with the city of Nolanville. Choose software, set up a test date, and evaluate that data we collect on the test date. And finally, we're going to finalize the project.
Okay, kind of to sum up what we've said throughout the presentation as we get ready for questions, we're going to test the application of the sensors that the computer science majors have developed. We're going to present the data to BNSF and the city of Nolanville, and we're going to involve the community by participating in a public hearing, hopefully the first week of April. Hopefully the sensors are going to do their job, but our main idea right now for an alternative would be the camera that Kunal mentioned in order to get the train data that's needed. We are working really hard to plan with the logistics of the city officials and make sure the sensors are working properly. So the next couple of weeks, our goals are to test the sensor here in College Station first before we head out to Nolanville. Gather and analyze the data, and then present the data to Nolanville at the public hearing. And then we also want to receive feedback from the residents and the city councils, and hopefully finally implement the final train warning system.